Welcome back to the history of artificial intelligence. In here, we are going to discuss a brief history of the area, and we are also going to explore some of the terminologies that emerged within artificial intelligence and that are used nowadays. For example, computational intelligence, machine learning, big data, all these can be understood as sub-areas of artificial intelligence, and I will try and position yourselves on when these terminologies were formalized and why they were created. Starting with the first period in the history of artificial intelligence, it ranges from before the 1950s until the turn of the millennium in the year 2000. In this timeline, I am dividing the first period of artificial intelligence, which I am calling here the past of artificial intelligence. I am dividing it into decades, starting in the 50s and going up to the year 2000. Until the 50s, a number of milestones happened in the field of artificial intelligence, and I want to start presenting you the 1943 model of a neuron. This was proposed by McCulloch and Pitts and became known as the first mathematical model of an artificial neuron. McCulloch and Pitts designed this model so that it could simulate logic gates. For example, the logic gate AND or a NOT, all of them could be simulated in this very simple mathematical model of a neuron. If we look at artificial neural networks and deep learning neural networks nowadays, most of them work with this very same type of mathematical neuronal model with a slight variation of this pioneer proposal, which was introduced over 80 years ago. Right? So it's very interesting to see how a structure that was proposed so long ago is still used in most of our neural network models. Then I want to detach here the publication of the book, The Organization of Behavior by Donald Hebb, in which he proposed the first learning rule for artificial neural networks. Basically, what he proposed was that the weight between two nodes or two neurons in a network increase if both neurons are activated or active at the same time. In 1950, Isaac Asimov published his novel called I, Robot, in which he introduced what became known as the three laws of robotics. If we look at these laws, we can see that the first one states that a robot may not harm a human being. The second one proposed that a robot must obey humans unless it contradicts the first law. And the third one says that a robot must protect itself unless it contradicts the first and the second laws. Although these laws have nothing really to do directly with artificial intelligence in the sense of guiding us in the learning process of artificial intelligence systems, they focused on an issue that is a hot topic nowadays, which is a discussion on what machines could and could not do. So this is a discussion about AI ethics. Right, so this is the reason why I decided to bring the laws of robotics here in our discussion about the past of AI. Finally, we have here in this picture an illustration what is known as the Turing test. And the Turing test was a test proposed by Alan Turing in the 50s, which aimed at evaluating the intelligence of machines. The idea is you have someone here in a closed room, and this person is interacting with another person and with an intelligent machine. But this person doesn't know who's the other person and who's the machine. If he or she is incapable of differentiating one from the other, then we can say that this is an intelligent machine. And it's very interesting because when we look at the essence of the Turing test is basically what we are trying to do with the chatbots and what we can say that we have been able to achieve only after the large language models were delivered. Before that, we had some initiatives, but nothing really could deceive us to the point that these large language models like ChatGPT and others are capable of doing. This discussion, as we can see, it has over 70 years, and it took over 70 years for a machine to be able to pass the Turing test. In the following decade, there are two events that I want to detach here in our discussion. The first one was the Dartmouth Conference that happened in the Dartmouth College in 1956. In this conference, a number of researchers who are investigating artificial intelligence related topics, including John McCarthy, Marvin Minsky, Claude Shannon, Herbert Simon, Arthur Samuel, and many others, they gathered together and started discussing artificial intelligence. And they brought this as a discipline as one of the results of their meeting. This is considered by many as the foundation of the artificial intelligence field as a discipline. And also, in the same decade, we had the proposal of a programming language called Lisp, which stands for List Processing, which was very convenient for the development of artificial intelligence solutions. In the following decade, we had another set of very important developments in the field of artificial intelligence. For example, in 1961, we had the first robot implemented at industrial scale in the United States called Unimate. Another very important development of artificial intelligence in the 60s was the proposal of ELIZA. ELIZA is an early natural language processing system developed with the goal of exploring the communication between humans and machines. Another important development in the field of artificial intelligence in the mid-60s were the expert systems. The goal of the expert systems is to incorporate the decision-making ability of humans. The problem is that expert systems, they usually simply take the knowledge from a human. For example, if something happens, do that. If this happens, do that. If that happens, do this. Right? So you're simply taking a set of rules and translating these rules into computer code to design your expert systems. So this is the main characteristic of expert systems. And finally, by the end of the 60s, we had the publication of the book called Perceptrons by Marvin Minsky and Seymour Papert. This book had a tremendous impact in the development of artificial intelligence because in this book, Minsky and Papert showed that some simple neural network architectures were limited in terms of the types of problems that they could solve. This book, Perceptrons, brought extensive discussions around artificial intelligence and neural networks in particular, because they not only show the limitations of the perceptrons, but they also argue that overcoming those limitations would be very hard. And this, to some extent, influenced the perspective over the whole field of artificial intelligence for a few years. When we go to the next decade of the field, which became known as the artificial intelligence winter, what we could observe was a lack of funding and a lot of discredit in everything that involved artificial intelligence. And this was not only due to all the pessimistic perspective given by the Perceptrons book, but also because mainly after Dartmouth College workshop, the research scientists in the field, they started creating a lot of expectations, a lot of hype, saying that in a few years we would have autonomous robots cleaning our homes, serving ourselves food, making food for us, and doing all type of complex tasks that we humans do. But the problem was that at that time, we didn't have enough computer power, we didn't have the solutions to several types of problems, including vision problems, including navigation problems. Data was very scarce, it was hard to get and hard to store, and we didn't have algorithms effective enough to solve a number of problems which are necessary to be solved so that you can have more intelligent systems and solutions based on AI. We were at a time when we were not ready to deliver all those promises in AI. And this made, as I said, a lot of discredit. Nobody wanted to fund, neither public agencies nor private companies wanted to fund research in AI. Then, in the 80s, some interesting developments occurred. I want to bring to your attention the publication of the two volumes called Parallel Distributed Processing. They were published by the Rumelhart and Collaborators group. These were organized volumes, they were edited volumes that brought together a number of works which were very important for the development mainly of artificial neural networks, but also for artificial intelligence as a whole. And what we could observe here were some pioneer works on deep learning with, for example, the review of the backpropagation learning algorithm, which is used in multi-layer neural networks. We also have papers here involving self-organizing networks, involving recurrent networks, and different types of algorithms for neural networks and concepts involving artificial intelligence. So I do recommend, if you like AI, if you want to know more about the classic works that we have establishing important developments, early developments in the field, so I do recommend that you have a look in these two volumes. And in this same decade, we had the first commercial developments of virtual reality goggles and gloves. Finally, we have the last decade of the past of artificial intelligence, which is in between 1990 and 1999, the year 2000. This was a very remarkable period for artificial intelligence because this was when some new technologies started to emerge in some very impactful areas as well. But before I go into the last decade of the past of artificial intelligence, I just want to make another comment between this decade here, because there are some people that say that during the 80s, we had the second AI winter, but I personally don't have this perspective because differently from what we observed here in the 70s, when really there was a lack of funding, not much was going on, everybody was worried about attaching their work to AI because this could be not very well received by the community. During the 80s, we saw this rebirth, mainly of the artificial neural networks field, and this rebirth promoted a lot of work. So it was still slow, I do agree, but I don't see that as a second AI winter. I see it just as a rebirth, as an area that was trying to find another way of presenting itself and of overcoming some challenges that it was faced in the past. And this is very common in science. Here in the 90s, we had, in 1994, we had the first World Congress on Computational Intelligence, WCCI. This conference was sponsored by IEEE, the Institute of Electrical and Electronic Engineers, and it brought together three fields of research: artificial neural networks, evolutionary computing, and fuzzy systems. In artificial neural networks, we had the International Joint Conference on Artificial Neural Networks. In fuzzy systems, we had the fuzzy IEEE, and in evolutionary computing, we have the Congress on Evolutionary Computation. Okay, so these three areas composed computational intelligence, and it still do compose computational intelligence. This was a huge congress whose first edition occurred in Orlando, in Florida, in the United States. Initially, it was a conference that happened every 4 years. The second edition was in 1998 in Anchorage, Alaska. The third edition was in Hawaii, in Honolulu, in the United States as well. Then the fourth edition was in Vancouver, Canada. The fifth edition was in Barcelona. And then from the fifth edition onwards, this conference started happening every 2 years. It occurred in many countries, including Brazil. In 2024, this conference occurred in Yokohama, Japan. And it's important also to acknowledge and to understand why this new terminology emerged. One of the reasons why computational intelligence emerged, it was because researchers who worked with one of these three fields, they wanted to detach their research areas from what became known as the classical artificial intelligence. And the classical artificial intelligence had a very strong connection with expert systems. And expert systems had already shown not to scale, in the sense that when you draw a rule, this rule is incapable of adapting itself to new scenarios. And also it's very important for you to design rules that scale with more complex environment. So rule-based systems are top-down approaches in the sense that you tell the algorithm how it should respond to each scenario. And as we discussed in the first part of this series, the idea of artificial intelligence is that the system learns either from data or by interacting with the environment. If you simply tell the system what it should do in each situation, then it's not really a system that is adapting itself to the environment or to the data that you present, right? And when we look at all the techniques that we are discussing here in computational intelligence, evolutionary computing, neural networks, and fuzzy systems, all of them are adaptive in the sense that they learn from the environment or they evolve based on their interaction with the environment. A few years later, we have the emergence of another field called machine learning. When we look at this book by Tom Mitchell, I selected this book here because this was the first book that formalized machine learning as a discipline. When you write a book with a new topic, you're basically telling the community that this new topic deserves attention as a discipline. And Tom Mitchell brought it together by selecting and presenting a number of techniques that were specifically tailored to deal with data. Machine learning emerged as a discipline to deal with data. And if we look at his initial proposal and the initial works on machine learning, you realize that most of them are techniques that were borrowed from statistics. This field of research emerged out of statistics. And of course, nowadays machine learning is a terminology much broader than it used to be when it was proposed. And again, I want to make another disclaimer here, which is the fact that if we search the literature, you'll find the term computational intelligence before that, before 94. You will also find the term machine learning before 1997, but I'm not going to argue that. What I'm telling you is that this event, the proposal of WCCI, the World Congress on Computational Intelligence, which came together with the edition of this book, Computational Intelligence Imitating Life, this was a milestone. This was a landmark for the perception of this terminology as a discipline. And the same thing I'm telling you about machine learning. Again, you find this terminology prior to that in the literature, but it was very loose. People still didn't see that as a discipline, but the publication of this book was very important as a milestone so that people could look at that and say, oh, okay, I've seen that book, I've seen that proposal, and now everything makes sense. Okay, so I think it's very important to make this disclaimer because some of you may say, well, I've seen machine learning before that. I've seen computational intelligence before that. Okay, I am aware of it. I'm just telling you that the very existence and the very proposal of these books and this conference were a landmark in the perception of the community of these topics as relevant, as disciplines that could be understood and studied as one single specific discipline. And also in this final decade of the last millennium, we saw the emergence of the RoboCup, of the competition of robots. And we also saw for the first time an intelligent machine, in this case, Deep Blue by IBM, to beat a human master player in chess, right? And again, if you want to assess the intelligence level of a machine, it's natural that we think of assessing this by making this machine beat a human being in something. So in this case of the RoboCup, what we wanted to see was the capability of the machines to play a sport that is human sport. And in this other case, what we wanted to see was the capability of the machine to beat a human being who is a world champion on something. In the case of Deep Blue, was on chess. With that, I conclude what I wanted to review in terms of the past of artificial intelligence. See you in our next part of the series, in which we are going to talk about the present of artificial intelligence.